All right, you algebrainians, let's talk some similar polygons today. Well, first of all, a similar polygon is a little different than a congruent polygon, because similar just means they have the same shape, but not necessarily the same size. So if I take a look here, I have two similar quadrilaterals. I have quadrilateral ABCD and WXYZ. And we have a symbol that we use for similarity. It's just kind of a little squiggly, like in a tilde on your keyboard. So if you take a look here, if I were to name these two quadrilaterals being similar to each other, I would use this statement right here. Obviously, I could change up the order like B, C, D, A, as long as they kind of go in order. But the most important things, they have to match up. Because if you look at A, that corresponds to what's vertice on the other quadrilateral? Well, W. And we'll talk about why they correspond here. But so I have to have A and W. If I start with A, then W has to start off in the front there. A and W, that's kind of funny. So then if I went to B next, that means I'd have to go to X next because they need to correspond. So on and so forth, just like that. Okay, so my statements, the vertices have to correspond to each other. They have to match up. Well, and this is why they correspond and why they match up. Because one of our properties, one thing that makes polygons similar is that they have to have congruent angles. Corresponding angles are congruent in similar polygons. So for example, angle A is congruent to angle W. Angle B is congruent to angle X. Angle C, happens to be a right angle, is congruent to angle Y. And angle D is congruent to angle Z. And that's why they match up. So A matches up with W, B matches up with X, C to Y, and D to Z, because they're congruent to each other. So corresponding angles are congruent in similar polygons, right? And it looks like it. That's why they have the same shape. But they're not the same size. So the side lengths are different, right? They don't have the exact same side lengths, but there is something with the side lengths. They are actually all proportional. Corresponding side lengths are proportional. Well, proportional means I get like having two ratios equal to each other, or setting like two fractions equal to each other. So if I think about that, for example, like AB, the side AB right there, that corresponds to side WX on the other guy. So there's one of my ratios, one of my corresponding ratios. It would be proportional to all the other sides that correspond. So for example, I could pick BC for my next ratio, and that corresponds to XY on the other quadrilateral. So there's one of the proportions I could set up. And I could just keep going if I would like. So for example, DC and ZY corresponds. There's another ratio, DC over ZY. And lastly, AZ and WZ. AZ and WZ. Okay, so all the corresponding side lengths are proportional. You just got to make sure, you notice how I had all the bigger quadrilateral on top and all the smaller, from the smaller quadrilateral on the bottom, and those have to match up like that. You can't flip-flop them, otherwise the proportion wouldn't be set up correctly. Okay, so those are the most important things. Similars, if they're similar, angles are congruent, side lengths are proportional. That's what we got to remember. So determine whether the pair of triangles is similar. Justify your answer. Well, I probably need to know all these angle measures. I don't know anything about the sides. Well, can I find out the rest of the angle measures? Sure. Doesn't matter which one you want to solve for. I'm going to go ahead and solve for W, because I know triangles add up to 180. So I take 68 plus 68, and I get 136. And I'm going to subtract that from 180 to find what angle W is. And in this case, I get 44 degrees. Well, and over here, I have my little symbols to show that they're congruent. So I know these both have to be 68. And that would make them similar. So I would say yes, angles are congruent. Or basically corresponding angles are congruent. So one way to determine if they're similar is to see if all the angles are congruent. Another way to see if they're similar is if their sides are proportional. And I can't just pick any two sides. All the sides have to be proportional in order for these two shapes to be similar. So I gotta look, well, 12 matches up with 8, so I can put 12 over 8. I could put 8 over 12, and then it's just gonna change what my second one would be. And then 15 corresponds to 10, so 15 over 10 would be my next one. And lastly, 24 corresponds with 16, so 24 over 16. And for them to be proportional, all these ratios have to equal each other. Well, let's go ahead. If I simplified all three of these, they should all be the same if they're similar. So if I simplify this first one, 12 over 8, 4 goes into both. 4 goes into here 3 times. 4 goes into here 2 times, so 3 over 2. Well, 5 goes into the next one. 5 goes into 15 3 times. 5 goes into 10 2 times, so 3 over 2, good. And then the last one, 8 goes into 24 3 times, and 8 goes into 16 2 times. So there we go. So are they similar? Yes. And to justify my answer, right down here, sides are proportional. So I don't have to say sides are proportional, I just showed it right here. There you go. How about this? It says find the missing measures for the pair of similar triangles. So let's go ahead. Let's solve for the measure of angle D up here first, because that one's pretty easy. I'm just missing one angle. So I add my 77s up, and then subtract 77 plus 77 from 180. So those add up to 154. Subtract it from 180, which means we have 26. That's 26 degrees. And it said that they're similar, so I know that corresponding angles are congruent. Well, they already matched up. These matched up. So I know that the measure of angle H also has to be 77 degrees. Or 26 degrees, my fault. Got talking too fast. 26 degrees. Because these two guys correspond, these two angles. H and D. Okay? What about the sides? I think we could solve for X pretty easily, because that corresponds with this one. And these two correspond. So if I set up a proportion here, I could put 18 over 27 for these two corresponding ones. And then I could set that equal to 18 over X. Well, I don't even need to do the cross product or anything like that, because I can just tell that X has to be 27 in order for those to be equal. So that one I didn't need to do a whole lot of work. But for this other guy, trying to solve for Y now, let's set this one up just a little bit different. I could do Y, that corresponds with 6. So I'm going to set this one up the other way. I'm going to say Y over 6 now. Y over 6. So if I do that, I can pick, I'm going to write this in, this is 27 for X. I can pick any of the other two corresponding sides. Well, since I started with this triangle on top, because I put Y over 6, I have to put one of these sides on top of the other one. Well, I'm just going to pick this guy. 27 over corresponds with this side, 18. So now I can use my cross product. Or another way I could have done it is, if I look up here, this 18 over 27, if I would simplify that, 9 goes into both, so there's 2/3. So basically I know that these top guys are 2/3 the bottom sides. So that's another way I could do it. But let's go ahead and do the cross product. So I got 18 times Y equals 6 times 27. And 6 times 27 gives us 162. And then we divide by 18, and we get Y equals 9. So there's quite a few ways, right? You can just look at how the ratios set up with each other, like how much bigger is one triangle than the other, or I can set up proportions, right? Because the sides are proportional when they're similar. Lastly, this is my favorite. It says, Marla wants to know the height of the tree in her backyard. The tree casts a shadow of 8 feet 6 inches long. Marla is 5 feet tall, and her shadow is 2 feet 6 inches long at the same time. How tall is the tree? Well, first of all, when I get stuff like this, drawing a picture is so helpful. But before I even do that, one thing you want to get used to is anytime you see different units in the same story problem, a good idea is to change them all to one type of unit. So for example, this first one, instead of saying 8 feet 6 inches, I could simply say 8.5 feet because it's 8 and 6/12, and 6/12 simplifies to 0.5. And down here, instead of saying 2.6 or 2 feet 6 inches, it's really 2 and 6/12, which 6/12 is 1/2, so 2.5 feet. So now I have all feet. I'm dealing with 2.5 feet, 8.5 feet, and 5 feet over here. So it's good to get it all in the same type of unit. All right, so let's draw our picture now. So I got a tree. So there's my tree, and it casts a shadow. I don't know how. Let's call this tree like this. There we go. Beautiful. Okay. And the shadow is 8.5 feet. So I can put that down there. Okay. And then it says that her shadow casts at the exact same time as 2.5 feet. So let's draw her about like, right here. So there's Marla. I'm going to draw this bigger. So let's draw a picture here. So we got a tree. Doop, 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 doop. And it's got a shadow. And that shadow is 8.5 feet, it says. Yeah, well, this kind of makes a right angle, right? That's kind of nice. And Marla is 5 feet tall. And her shadow is 2.5 feet. So let's say Marla, she's over here. There's Marla. Yeah, didn't really give her eyes and stuff. That's cool. And she's got a shadow that's 2.5 feet. 2.5 feet. Well, she also makes a right angle there. Well, oh yeah, wait. She's also 5 feet tall. Let's put that in there too. So she's 5 feet tall. Well, what do I notice? I could turn these guys into right triangles. Boom. So they're similar polygons, right? Because they have the exact same angles, because they have the exact same shadow. Because you got the sun up here, and if it's at the same time, these angle measures are going to be the same. I'm going to have the exact same angle measures. So that means these are going to be similar triangles. Well, I should be able to solve for the height of this tree then. All right, I can set up a proportion because sides are proportional. Well, I'm going to put her height over the height of the tree because they correspond. And then I'm going to put her shadow, right? Because I got to have her stuff on top and the tree on bottom, or vice versa. Tree on top, her stuff on bottom. It's got to match up though. So then her shadow on top over the tree's shadow. And then we take the cross product. So 8 times 5, that's an ugly arrow. So 8.5 times 5 is 42.5. And then 2.5h. And we divide by 2.5 on both sides. So h gives us a height of 17. And it looks like we got it all in feet, so 17 feet. So it's kind of fun. You get to draw yourself a little picture and just applying what we learned. There we go.